So we continue, ne? Let us continue. They say that the equation of a circle with that equation of a circle. So now remember, in the previous video we were dealing with the circle where the center was the origin. Now the center is no longer the origin, right? So that means we are talking about a circle that could be anywhere else on the Cartesian plane. We just know that the center is not the origin. I'll just give one possible example of that kind of a circle. So we can have a circle, a circle like that. You see that circle, the center is not the origin. Or we could have this one, right? The center will definitely be probably somewhere here and not here, right? So there are just the multiple examples of this kind of a circle, right? So for our illustration, let me use the red one. So you have a center here. Say the center is what? Let me call it pi, man. Let me call it k, right? And the coordinate is a, b, right? And we have another point on the circumference, which is p having x, x, y. Do you understand? And we have our radius, right? Of course, line from the center of the circle to the circumference is a radius. Now I'm like, okay, find me the distance, right, for my radius, right? You will say, I cool, this is r. You would say the distance for kp, right, is gonna be square root of what? You have y1 minus y2 squared plus x1 minus x2 squared, right? That is the formula. And now you substitute. So you have square root of y1, that is a b minus y, right? And then here you have a minus x, right, squared, right? And this is your radius, né? And you square both sides, you get r squared equals to b minus y squared plus plus what? A minus x, right, or squared. You understand? I don't like the way I wrote it, right? So perhaps let's go with the structure. It's still the same. You can say y minus b, right, plus x minus a, right? That would still have the same meaning. Yeah, well, or the answer of both the green radius squared and the red radius squared, is the same value, right? Cool. So let's now work on some examples. Remember I said I'm gonna use this one, eh? So let us also use that, because also like you can get this one if here you mentioned that you have a square root of what? Y minus b squared plus x minus a squared. Then you'd have the red thing, right? So yeah, I'm gonna use this one. F, right, is a point on a circle with a center. Draw a rough sketch of the circle. Okay, so let's draw the circle. Let's draw the circle. So where is the center? Here's the center, 3 minus 4, right? Say this is the point, right? 3 minus 4. And where is this point? The one that is on the circumference. It's 6 and minus 4. Okay, so it's gonna be somewhere here. This is a point F, 6 and minus 4. right? So with this, that means my circle is gonna be something like this. Right, and allow me to say not drawn up to scale, né? Yeah, just allow me to say not drawn up to scale. But it looks way too bad. Yeah, it looks way too bad. Let me do this and then resize. Cool. Way much better. Way much better. Cool. So I have my circle there, and there's, of course, this is point the center. Cool. But I draw a rough sketch of the circle and label F. We have drawn a rough sketch and we have labeled F. Determine the equation of this circle. So we know we have what? We're gonna find r squared, and we know r squared is y minus a squared plus x minus b squared, where a and b is the center of the circle, right? A, B, those points, they are the center of the circle. So now you just come here, you know this is the center, so you use that. You say minus 4 minus 4, right? Is that real? So you have minus 4 minus a, which is minus 4, so that is, yeah. Then you have x, which is 6 minus 3, right? You squared 6 minus 3, and you have, perhaps let me put the whole thing in a calculator. That is gonna be that is gonna be 0, it seems. But why minus 4 minus I mean, yes, it makes sense. So I'm gonna have 0 here, so I'm just gonna say 3, 6 minus 3, right? It's 9, and then you square it. That is 9, so we have 9 here. Yeah, we have 9 there. Therefore 9 equals to y plus 4 plus x minus 3. This then becomes the equation of the circle. So remember, this plus 4 is coming from the minus and the minus, right? They're gonna make a positive, and this is the y value, so y plus 4 and then x minus 3. Let's see. Does point G lie on the circle? So point G, to see if it lies on the circle, we're going to substitute this point, right? Let me put it here. Point G is what? 3 over 2 and then minus 2. 3 over 2 and minus 2, right? So with this, they are asking if this point lies on the circle. So I'm gonna substitute these two values here for x and for y. If I don't get 9, I know they don't lie on my circle. Wait, let me see. Yeah, they don't lie on the circle. They don't say in the circle, they say on. So yeah, so I will say y, which is minus 2 plus 4, minus 2 plus 4 squared, plus I have 3 over 2 minus 3 squared, and that is gonna be minus 2 plus 4 plus 3 over 2 minus 3 squared, and I am getting 6.25, right? Perhaps let me write it as a fraction, which is not 9, and therefore my conclusion is that this point, it does not lie in my circle, right? Yeah, it doesn't lie in my circle, right? Let's see the next question. The question is, does the circle cut the y-axis, right? So does it cut the y-axis? Now let's think, what is the y-axis? I mean, it is the y-axis, but what happens on the y-axis? X is equals to 0 on the y-axis, right? So now with that clue, what do you think how do you think we're going to approach this question? Right, just remember, y-axis is a any point on the y-axis, x is 0, right? Cool. So to answer that, let's find the y-axis. Let's find the y-axis. I just want to remove this, create more space. Cool. So y-axis, x equals to 0, right? So we'll solve 9 equals to y plus 4 squared plus 0 minus 3 squared, right? So now let's expand this. You have y squared, 4y times 2, that is 8, plus 8y plus 16 plus 9. Alright, we also have a 9 here. So the thing is, these two 9s, they're gonna minus each other. So you have 0 equals to y, basically y plus 4 squared. In fact, it seems we didn't have to expand this, right? Because once these two are gone, right, you have this, and which when you factorize it, it gets you to that, right? Which says therefore y is going to be what? Y is going to be minus 4. All right, so because of this, then you would say yes, the circle, it cuts the y-axis at 0 minus 4, because remember, y-axis, x is equals to 0, right? So if you did this workout and there was no solution for your factor, like there was no solution for your y, yeah, say you are here and you realize that there's no solution for that y, then you would then say that no, it doesn't cut the y-axis, and the same is true, right? A good way is, say for an example, you can use your quadratic equation, right? You know your quadratic equation, there inside you have b squared minus 4ac. The point where you won't have a solution is if you get a negative some value, square root of negative some value, and then you would say it seems that there's no solution, and therefore our circle doesn't cut the x-axis or the y-axis, depending on what was the question based on. Was it about the y-axis or the x-axis? Cool. So now they gave us the coordinates of the circle, né? Cool. There's an interesting one. It's something new. When you have the equation and they want to find the radius, né? This is how you would approach this question. So you have 3x squared plus 6x plus 3y squared minus 12y minus 3 minus 33 equals to 0. So it seems that there's a higher common factor of 3. So let's divide by 3, right? Divide by 3, 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 divide by 3. So I have x squared plus 6 plus 2x plus y squared minus 4 yes 4 yes 4 12 divided by 3 4 yes 4y and then minus 11, right, equals to 0. So now let me take the 11 and I have x squared plus 2x plus y squared minus 4y. Now this is not the standard form of a circle, of the equation of the circle. The standard form is not like this, so we have to put it in that form, because the mistake is someone could think that there's the radius squared, which is not, right? So how are we gonna put it in such a way that you have your bracket squared and a bracket squared equals to your r squared by completing squares? So let's do that. We start here. You have x squared. We look at the center. We look at plus 2x. Look at the coefficient of the center is 2. You divide that coefficient by 2. So 2 divided by 2 is 1. And then you're gonna say plus 1 minus 1, right? But remember, plus 1 squared and 1 squared. Cool. And then for y, right? For y, we have y squared plus minus 4y. So you like, what's the coefficient of y? This coefficient is 4. Let's divide it by 2. We get 2. And now we square it, right? So here we're going to add the square. So it's 2 squared plus minus 2 squared, right, equals to 11. And then we're going to group the first 3 terms, right? We group the first 3 terms, which would then mean here you're going to have x plus 1 squared, right? And then you still have that minus 1, right? Plus here you're going to have y minus 2, this 2 squared, right? And then you're still going to have that minus 4 equals to 11. And now you have x plus 1 plus y minus 2 squared equals to 11 plus 1 plus 4. So now 11 plus 1 plus, okay, this is 16, x plus 1. Oh, I forgot the squared here, sorry for that. Squared, and there we go, right? From that, then you conclude that I think we had to determine the coordinates of the center and the length of the radius, right? So from here you see, remember, the structure is like x minus a squared plus y minus b squared equals to r squared. All right, so from this structure you will say r squared equals to 16, right? And therefore r is gonna be 4. Remember, r can only be positive, so you won't do your plus or minus 4. Now let's come for the points, right? Remember the center, right? The center, it looks like this, a and b. So from here that means therefore you have minus 1 as a and you have 2 as b. So when you come there for minus a, it's minus 1, which makes it x plus 1. And then for here you have b minus y minus b, which is y minus 2, and that's it. So you have the coordinates and you have your distance, and you are done. Let's do this. This will be the last set. So they say again, where to determine the center and the length of the radius. So okay, determine whether the circle cuts through. Okay, cool. So for this one, for a, same thing. You have x squared. There's no any other point, cool, plus y squared minus 4y equals to 21. Ne? Equals to 21. So here I can just say x squared. Now I can just say x minus 0 squared plus y squared minus 4y. I take the value divided by 2, I get 2. So I'm going to have plus 2 squared minus 2 squared equals to 21. And I'm going to have x minus 0 squared plus, remember now I group the first 3, and that means I'm going to have y minus 2 squared minus 4, 21, and then x minus 0 squared plus y minus 2 squared equals to 21 plus 4, which is 25. Right, so that would mean, of course, here r squared equals to 25, therefore r equals to 5, and then the center is gonna be 0 and 2. Right, yeah, and then everything then makes sense. Right, let's do the second one. So the second one, let's transpose everything apart from 5. Or maybe let me, yeah, I'm gonna have 5 equals to x squared minus 6x plus, it can't be minus, so it's gonna be plus, and then plus y squared plus 8y, so yeah, everything is gonna be plus. Then you do your completing squares thing. You divide the number by 2, you get 3, so therefore you're going to get 3 squared minus 3 squared. Right, let's go focus on y plus 8y. Divide 8 by 2, you get 4, so you have plus 4 squared minus 4 squared. And you group the first 3. Group the first 3 terms. That means you have x plus, you look at the sign here, plus 3 squared, then minus 9, and then you're going to have a plus y, the sign here is plus, so plus 4 squared minus 16, right? And you realize here you have x plus 3 squared plus y minus a plus 4 squared minus 25. Ne? Yes. So from this 25, you transpose it to the other side to say 5 plus 25 x plus 3 squared plus y plus 4 squared, and then you have this being equals to 30. Then you would say, therefore, you would say r squared equals to 30. Therefore, r equals to square root of 30. And the center is going to be minus 3 minus 4. And there, bro, you are done with this question. Let's see. Does that circle cuts through or touches the x and y intercept? So it's just like I told you. Let's start finding x-intercept. X-intercept, y equals to 0. So you have x squared minus 4x plus 0 squared minus 6 into 0 plus 9 equals to 0. That means you have x squared minus 4 plus 9, right? 4x and equals to 0, right? And by the way, this, let me see. Yes, is that so? I have 1 and 9, and then I have 3 and 3. Okay, so this one I can't factorize it the normal way, so I'm going to use x. I'm going to use the quadratic equation. So I have minus b plus or minus square root of b squared minus 4ac. What do I have? What do I have? 2a. Yes, thank you. And here I substitute. I'm going to have a positive 4 plus or minus square root of, that is going to be 16 minus 4 into 1 into 9, right? And I'm already seeing there is a problem. There is no solution for this, right? I will just show you now. So it's 16 minus 4 times 1 times 9 is minus 20. So we're going to have a minus 20 here over 2, and you would say no solution. No solution. And no solution, what does that mean? It means it doesn't cut through the x-axis, right? Therefore we don't even have x-intercept, right? So cool, we have proven this thing doesn't cross or touches the x-axis. Now let's show that it doesn't, or maybe it does, cross the y-axis. So y-axis, x is equals to 0, so that means you have 0 squared minus 4 into 0 plus y squared minus 6y plus 9 equals to 0, right? Yeah, and then of course you're gonna have y squared minus 6y plus 9, right, equals to 0. You realize this, it can be factorized. It's gonna be y minus 3 into y minus 3. This is how you factorize this, and therefore you see that y is going to be equals to 3, right? And then here you would say okay, still need to remove this, and this one you would say that therefore the circle cuts the y-axis at 0 and 3, right? Sure thing. Yo. All right, cool. I'll see you guys in the next video.